So the homework is going to be dealing with looking at Q and K, and I'm going to look at this question here. So this is an equilibrium, has N2 reacting with H2 and forming ammonia, NH3. And it says at the start of the reaction, there's a certain number of moles of each thing. So there's N2, H2, and NH3 in a 3.5 liter reaction vessel. If the equilibrium constant K, C, is 1.2 at this temperature, is the system at equilibrium? If not, decide which way we will proceed. So this question involves figuring out something called Q, which is the reaction quotient. So Q is the reaction quotient, and that is non-equilibrium conditions. And we're going to compare it with K to see what happens if I have Q bigger or smaller than K, and then what direction the equilibrium needs to shift. So I have written out here the conditions. We start off with different moles of everything, and I have a volume. And if you remember, Kc is using concentrations of things. So I have concentration of NH3 all over concentration of N2, and then H2 raised to the third power. And because they're concentrations, we need to actually calculate concentrations or molarities. So how do I do that? Well, I have a volume, I have moles. I take each of these things and divide it by the volume, 50. Okay, so you get these three numbers, and I'm going to pause it here while I do this. So I've gone ahead and calculated the numbers. These are my molarities of all three things. And what I'm going to do now is just plug it into the expression. Now I know that K is this, but Q is also the same as K. You'll ask, well, why do I even bother writing this out again? Well, Q, remember, is non-equilibrium conditions. K is at equilibrium. And we know what K is. K is 1.2 from the problem. So K in this problem here was 1.2. Okay? So I know that Kc is 1.2, but I need to take these numbers here now, and I'm going to plug them into this equation. So I plug them in here, and I see what I get, and now I'm going to compare it to K. So we'll do that in a second. So I have my concentrations calculated now. I figured out the concentrations, the molarities of each of these. And like I said, we're going to calculate Q. Q is the reaction quotient non-equilibrium. I just plug these numbers into here. So you just go ahead and plug them in. And in the calculator, it kind of looks like this. Okay, so I have it plugged in. It kind of looks like that in the calculator. And if I hit enter, I get this number. So you should get 0.6135, which is Q. Remember, this is at not equilibrium. This one here is at equilibrium. And so, are we at equilibrium? Well, no, these are not the same. So since Q is smaller than K, so we have Q smaller than K here, what does that mean in terms of what direction the equilibrium needs to shift? So because this is too small, that means which side has got to get bigger? Well, the numerator has to get bigger now. For the numerator to get bigger, I look at my equilibrium. That's this thing here. And that means I need more of my products. So we say that the equilibrium needs to shift to the right. Okay, so it's got to shift to the right to reach equilibrium. If Q is greater than K, it's the opposite. If Q is bigger than K, that means we need more products, so we need to shift to the left. And then if Q is equal to K, we are at equilibrium.